Hours. In this episode, we're going to be learning about BGP communities and specifically the local AS community. That said, let's start. The local AS community is a well-known BGP community that can be used for BGP confederations. It's basically the same as the no export community, but this one works for within the sub AS of a confederation. Prefixes that are tagged are only advertised to the neighbors in the same sub AS, not to other sub ASs or eBGP routers. So we're going to be using this topology, which I have not configured yet, but I've added all the links the same way it is in the diagram. So I'll probably have to do all that before we insert some BGP configurations. But before that, let's see what the author has to say. He says AS2345, which encompasses R2, R3, R4, and R5, has 4 routers and 2 sub-autonomous systems. We will advertise a prefix from R1 to AS2345, so you can see what happens with and without the use of a local AS community. Let's take a look at the configurations, but before we do that, let's start configuring the IP addresses of these interfaces. So interface loopback 0, IP address 101.1.1 slash 32. Interface FA00, IP address 192.168.12.1. It's a slash 24, do no shut there. I think that is all I need to do for now. So let's go to R2, interface FA00, an IP address of 192.168.12.2 slash 24, no shut. Interface FA10, and give it an IP address of 192.168.24.2. Same subnet mask, no shut here. And lastly, we have FA01, and this will have an IP address of 192.168.23.2. Alright, I'll no shut this as well. And I believe that's all the interfaces we have to configure at R2, so let's move to R3. And yeah, we're going to configure, which interface are we configuring? FA01, IP address of 192.168.23.3 slash 24 subnet all around, no shut. Interface FA10, IP address 192.168.35.3, no shut. Lastly, we have interface FA00. We'll give that an IP address of 192.168.36.3. And we'll no shut this as well, and we'll move on to R4. In R4, we'll configure FA00 with an IP address of 192.168.24.4. Same subnet mask. Turn up the interface. It's FA01, IP address 192.168.45.4. No shut here. And I believe that's all the interfaces we have to configure here. So let's move on to R5. Configure interface FA00, IP address 192.168.24.4. Give that a subnet mask of slash 24. Wait a second. I am not looking at the right router. Yeah, we do configure FA00, but it's with 192.168.35.5. interface FA01 with an IP address of 192.168.45.5, and we'll do no shut here. And in the last interface, I forgot to no shut, so we'll have to do that right here. So FA00 no shut, do an end, and we're going to move on to router 6. Router 6 only has one interface, which is FA00. You have that, an IP address of 192.168.36.2. No shut that. And we could now start configuring BGP. So per the author, on router 1, we'll set it so that the autonomous system number is 1, and we'll do a network statement of 1.1.1 to advertise this prefix out, and we'll set a neighbor of router 2 in its autonomous system number of 2345. And yeah, I think that's all I have to do. So let's move on to R2. And over to R2, we'll do router BGP 23, and we'll do a new command that we haven't used before. And that looks like it's going to be called BGP Confederate. Or, wait, does it even support BGP confederations? There it is. And we'll set the identifier as 2345. And another statement that we haven't used before is BGP confederation peers 45. And I think that is how we're going to peer with R4 and R5. So BGP confederations, peers 45. I wonder if you can add more. Yeah, you can continually add more AS numbers. What else? We have a neighbor statement of 3.3.3.3. Why do we have that? I suppose it's because router 3 has a loopback interface that is configured, but it's not in the diagram. So I gotta actually scroll down to the very bottom to see if he actually created a loopback address for router 2 as well. And I'm gonna do that really quick. Over here we see that the author did configure a loopback 0 interface for R2, which is not shown in the diagram. So we'll also configure that. How about I do that right now before I forget? So give that an IP address of 2.2.2. It's a /32 address. And we'll go back to BGP configurations. Let's see. Okay, so we'll have a neighbor of 3.3.3.3, which is going to be router 3 if the author is following convention. And that will be in the same autonomous system of 23. And we'll use the update source loopback 0 command. Oops. 3.3 update source as loopback 0. And over at neighbor router 4, we're gonna configure their AS as 45. And we're also going to configure a multi-hop Oops. Of 2 so that it can reach its loopback address. And we have another statement where we have the update source from the loopback 0 interface. Lastly, we have neighbor 192.168.12.1, and that is going to be for router 1. Alright, cool. I think that is it for router 2. And I want to do a write mem on R1 as well. Alright, now we're going to R3 to first configure a loopback address of 3.3.3.3. Then we're going to configure BGP with an autonomous system number of 23. And then we'll insert some confederation commands. We'll tell it confederation that it belongs to 2345, and that it will peer with autonomous system 45. Peers with 45. Then we have some neighbor statements to configure. Remote AS23 for router 2. Update the source as the loopback interface. We have neighbor.5.5.5 for router 5. And we're going to configure eBGP multi-hop so that it'll be able to reach R5's loopback address. Oops. Wait, did I even do it for... No, I didn't insert the neighbor command yet. So I have to do that before configuring multi-hop. So that's the error that I'm getting. 5, neighbor 5.5, eBGP multi-hop 2, neighbor 5.5.5.5, and we'll configure the source for the BGP updates as loopback 0. Lastly, we have router 6. So neighbor 192.168.36 .6 with remote AS6, and that should be it. Let me see if the BGP table has anything yet. It does not. But does router 2 have anything to show IP BGP? Alright, so router 2 does have the 1.1.1/32 prefix, and why is it not passing it along to R3 is why I'm kind of curious right now. Is it because the neighborhood relationship isn't on? Show summary, I believe. Alright, so it's formed. Oh no, it's in active state, so something is up between R3 and R2. IP interface brief. It's because some of my interfaces are down. No, they're up. I'm going to R3 show IP interface brief. And they're all up on the site as well. It's because, no, the loopback interface is already up. And this loopback interface is up. So, show run section BGP. Alright, so we see that we have the right statements. Show IP BGP neighbor. Oops. Show IP BGP summary. Okay, the only autonomous system that R2 was able to peer with is R1. It's not peering with routers 3 and 4. Well, R4 is not configured yet, but I'm wondering why it's not forming a relationship with R3. So let's bug. Oh, okay. So the problem is that R3 does not have a route to 2.2.2.2, and I'm thinking that the author probably input a static route, but to check, we're gonna see what he actually did. So over here we have R3. I don't think he did anything. So we're at R2. Did anyone raise the question? Or is this... I mean, how does R3 know how to get to R2? Does R2 have any network commands? Why is this in there twice? It's kind of weird. And why is no one asking the same question that I'm curious about? Alright. What else do we have? Are these routers secretly participating in OSPF? Is that why they know how to reach each other's loopback addresses? I mean, we have R6 here as a loopback address of 6.6.6.6, and how does R5, or I'm sorry, R3 peer with R6? Okay, it peers that way with the interface IP. So that should be fine. But and we could, I wonder if we can do it like, all right, so R2, can I just hack this in? Configure T router BGP 23, and we're gonna do network. We're gonna do 2.2.2.2, and we're gonna give it a mask of /32. And then we're gonna go to R3, and we're gonna pretty much do the same thing. So I will do a router BGP 23, and I'm gonna use the network statement, and I'm gonna advertise its loopback address out. And I hope this works. Yep. Show IP BGP. Yep. Yep. Alright, so it's all still in active state. What if I were to clear? They're still all in active state. There's no route to peer. Right, that makes sense. It's because the only way R2 currently can learn about 3.3.3.3 is to first form a BGP relationship with it, or establish, I mean. So there's no way that would have worked. Oops. So in that case, what can we do here? An alternate solution, I think, is if we go to R3 and we do so one option is to configure static routes, and the other is to configure OSPF. I'm going to do the static route method. So over at R3, I am saying to get to 2.2.2.2 with a mass of 255.255.255 dot 255, since it's a /32, you're gonna use this interface. And to get to router 5, we're going to use this address. 5.5. R5 is not going to respond because it's down. And here, show IP BGP. BGP neighbors. Oops, I want summaries actually. That did not seem like it fixed the issue yet, probably because I need to do the same thing over at R2. Alright, so configure T, IP route, and let's get to 3.3.3.3 with a mask of /32. We're going to use 192.168.23.3, and to get to the connection established, to get to R4, we're gonna set this static route and tell it to use 192.168.24.4. And now we'll start configuring R4. So let's see, router BGP, and this will be autonomous system number 45. Moving back up here, we're going to assign a confederation identifier of 2345. Confederation identifier 2345. BGP confederation. Peer. It's going to peer with autonomous system number 23. And we have a neighbor statement to router 2. We're also going to configure multi-hop. I'm going to set the update source as loopback 0. And the reason why it's not taking most likely is because I haven't configured the loopback address here yet. So let me do that right now. IP address 4.4.4. Back to our router configuration. So neighbor 2.2.2, update source as the loopback interface. And what else? We have to peer with router 5. So here's a neighbor statement for that. Remote AS45. And then we have to update our sources from loopback 0. And I think that's it for router 4. All right, moving to router 5. I think I have to create the loopback interface here as well. Address 5555. The /32 summit mask. And then I'll configure BGP with autonomous system 45. Give it a confederation identifier of 2345. And this confederation will peer with autonomous system 23. And the neighbor we're going to configure first is router 3 with remote AS23. I'm going to configure multi-hop on this. with 2, and we're gonna set the update source as loopback 0. And one last neighbor to configure. That's gonna be neighbor. Wait a second. Yeah, neighbor. Huh? Did I do this correctly? So neighbor 3.3.3.3 is for router 3. So I did eBGP first. So now I'm working with iBGP. Alright, so neighbor 4.4.4 remote AS 45, and we're gonna update source as loopback 0. Alright, and we have one more router to configure, so that's router 6. And looks like this one's easy. Just one neighbor statement for R3 as a peer. And that looks like it's it. Alright, so let's move over to R2. And let's see where we're at. Show IP BGP summary. We will see that R4 is still in active state, and it's failing because it's not responding, and I think it's because it has no route on the routing table to get to R2. So I'll have to configure a static route in that case. I'll exit out of router configurations. I'll do IP route. What is it? 2.2.2, and the subnet mask of a /32. To get here, we'll enter it through 192.168.24.2. And I probably have to do the same thing for R5. So to get to 5.5.5.5, we're going to enter through 192.168.45.5. Right, I'm here, and I'll go to R5 so I can create some static routes here as well. Exit out of router configuration to get to 4.4.4. We're going to use 192.168.45.4. Okay. Inconsistent address and mask. Why? IP route 4.4.4.4. Oh, because I didn't type the last 5 in the second octet. So that's probably why. 192.168.45.4. And sweet. The neighborhood relationship or adjacency came up. Alright. And I think I have to configure some static routes over at R3 as well, but am I missing anything here? I don't think R5 knows how to get to R3, but let me check. Show IP BGP. Show IP route. Knows how to get to R4. Knows how to get to itself because it's connected. So in the case, IP route 3.3.3.3. We'll use 192.168.35.3. And then we'll go back to R3. Looks like we're gonna have an adjacency come up from R5 since we just completed configuring R5. Show IP interface brief. Alright, everything's up. Show run, include IP route. Alright, so I've already configured the static routes for R2 and R5, so that should be fine. So I do a show IP BGP summary. Everything should be in established state except R6 for some reason. So going over to R6. Everything is up. But what's wrong? I think this is the problem. Can R6 peer with a confederation autonomous system? That is what I don't know yet, and that could be why it's not working. But going back to R3, show run. Let's do this. Show debug IP BGP. So we'll kind of see what's going on. Alright, it looks like it failed to send an open message. Is that what it's saying? Going back to R6. I mean, show IP route. When I did on 168.36.3, it does have a route there. All right, let's check out what they did. So, create a route map, and they set the community as local AS. But do they ever do anything with R6? No, they don't. Alright, so for R6, I'm going to change this number right here to 23 only. Let's see. Router BGP 6, and for our neighbor 192.168.36.3, change the remote AS number as 23. And clear. Oh no, I think it's gonna work without me having to clear the IP cache. Maybe, and maybe not. go over to R3. It's still not responding. Why is that? Is it because of cache issues? All right. Let's see. Over at R6, and it looks like we're experiencing the same issue. Show IP BGP summary, it's still in active state. Alright, 192.168.36.3, and that is the correct AS numbers. It's in AS6, and R3 is in AS23. Alright, let's move back to R3. Run interface FA00. Yep, it's correctly configured. F0. Was it F0 over here as well? Yeah, it was F00 here too. So what's wrong? Why will it not work? Show IP route. 192.168. I mean, it's gonna have it. Obviously, it's connected. .2. Show run. Oh, it's probably because of this right here. I thought the author was going by convention, so that would make the last octet the same as the router number. So in this case, it would be R6, so it would be .6, but it looks like he actually used .3 for some reason, which does not follow the convention of all of his previous lessons. So let me fix that. No neighbor, 192.168.36 with remote AS6. Yep, sorry. .6, then we'll redo it with a .3 or .2. Yeah, even in his example, no, it's correct, sorry. And R3. Yeah, he does mess up in the example as well. So over here he has the neighbor statement for router 6, where he does follow convention. It's using the 192.168.36 subnet, and the address is 6. So that was expected to be on R6, but in the diagram it shows a .2. So Yeah, that is probably the problem. But let me double check. So it's configured with a .2. So therefore, this neighbor statement should be a .2. Alright, going back to ARM3. Alright, that should fix the peering issue. And I say should, because it looks like it's still having issues. Oh, that's why. Because I didn't know. Neighbor 192.168.36.2. Remote AS6. Okay, now that should work. Otherwise, I'm going to, rip my hair out, even though I don't have any. Alright, it's an active state. Alright, looks like it's active now. Or it's, no, it's still having issues. What's happening now? So, it does actually get to open send. Oh, it's because within the open message, it contains an AS number, and I suppose the AS number is mismatched. So that's probably why it's not peering. I'll run section. Okay. Okay, let's change that remote AS to 2345 back to where it was. What are BGP? Oh man, I need to turn debug off. What's this? Ton of system 6. Neighbor 192.168.36.3 with remote AS 2345. Will this work? Show IP BGP. Okay, yeah, it worked now. Cool. I think I learned something new by trying to troubleshoot this. If a router is configured with a confederation AS, then for another router to, but then R1 is peering with R2, who is in AS 2345, but I don't think we used remote AS 2345 at R1, but I might be wrong. So show. Yeah, alright, show run. No, it looks like we did, actually. Yeah, we did, I'm sorry. I messed up. Alright, it makes sense now. So, in order for eBGP routers to form or to peer with routers that are in a confederation, they have to peer with remote AS of that of the federation identifier instead of the internal BGP AS. I don't know if I'm saying that right, but that's as far as I know, since I have not gone through the lesson of confederations yet, nor have I done it in a real production network. So that's new to me. Anyhow, we're 50 minutes in and we're not even done. So what do we do here? Over at R2, we're going to configure a route map of local AS. We're going to permit sequence number 10. We're going to set the community as local AS. And then we're going to configure BGP again. And for our neighbor at 192.168.12.1, which is router 1, we're going to apply the route map local AS, the one which is created inbound. I messed up. Route map local AS in. We're going to be doing it, inbound. And for neighbor 3.3.3.3, we're going to send community. But we're not issuing the send community command for the routers in AS45. And right map, and I'll do a clear IPBGP asterisk. Alright, so over at R2, do show IPBGP summary to make sure everything is up, and show IPBGP so that we can see some prefixes that are passed. And we do show IPBGP specifically for 1.1.1.1. What are we going to see? We're going to see that a community of local AS is flagged in this prefix. So in that case, we go to R3 and we show IPBGP. We do see the 1.1.1 prefix, and we do a show IPBGP 1.1.1.1. We're going to see that community flag as well. And if I try to ping 1.1.1.1, is it going to work? It's not. It's not because R3 does not really have a route to that interface. So in this case, I'm looking at R2's configuration, and I mean, it should be able to. The next hop would be R2, and R2 should know how to get there, I think. Alright, going back to R2, to show IP route 1.1.1.1. It knows how to get there. For at R3, show IP route 1.1.1.1. It's not on the table. Show run section BGP. Oh, right. So, question is, does router 3 know how to get to router 2's loopback address? So going back to R3, show IP route 2.2.2. It knows how to get there. I am a bit stumped. Oh, right. We can also verify that for R4 and R5 and also R6, we shouldn't see the 1.1.1.1 prefix there. Yep, and I'm not going to do it for the rest of the routers. So let's go over to R2 and we'll do show IP BGP neighbor 3.3.3.3 advertised routes. And it looks like we are advertising the 1.1.1/32 network, and we're telling router 3 that the next hop is 192.168.12.1. Which I don't think R3 will know how to get to. But I always thought that that the update source. Oh wait, it's supposed to be next hop self. So let me do that. Next hop self. How about that? It's not there. So going back to R2, we will configure BGP. And for neighbor 3.3.3.3, we're gonna do next hop self. And I hope this fixes it. So we'll run that same command. And it looks like it's still telling R3 that the next hop is 192.168.12.1, which R3 has no knowledge of how to get there. Let me do it. Let me clear the cache. And it's still doing it. Why is that? Why is that? But okay, no. It looks like it's fine now because it's saying to get to the 1.1.1.1 network, we're gonna use router 2. So let's try to ping 1.1.1.1 now. Oops. And it still doesn't work. Why is that? Why is that? Why is that? Show IP route 1.1.1.1. Yeah, I mean, R2 could ping it. But R1 doesn't know how to send a ping reply back to R3 because it has no routes to R3. Right? So that's not going to work. We're going to have to do that ourselves. Alright, so clear T. And we're just going to do it the old-fashioned method. We're going to do IP route to get to 3.3.3.3, which is going to be the source of the ping. We're going to go through 192.168.12.2, which is router 2. Right, and I'm going to try that again. Oh, still no good. Still no good. Should IP route 3.3.3.3. Can I ping 3.3.3.3? can't I? Show IP route 101.1.1. Yeah, it's going to go through 2.2.2.2. Does it just get lost in R2? Show route or show IP route. That exists. And how about 3.3.3.3? Yeah, it also has a method to get there. I don't know. I'm a bit stumped here. What if I try to ping not R1's loopback address, but R1's FA00 interface? 68.12. Nope. Show IP BGP neighbors. I mean, no, this is not what I want. What am I looking for? Show IP BGP. IP route 2.2.2. It's fine. A ping. Let's see. What am I missing? Anyway, let's see. Let's go to part 3. Over R2, show run section BGP. if I do this? Alright, we'll say it's inaccessible. But over here, this is the author's output. And it doesn't say inaccessible in the author's output. Does that mean the author created a static route to 192.168.12.1? Let's try to do that. IP route 192.168.12.1. Give that a /24, and to get there, we'll send the packet to router 2. Inconsistent address and mask. And this is /24, right? Why can't I do this? Show IP route 2.2.2.2. How about this? IP route 92.168.12.1, and the mask is this. We'll set it to 192.168.23.2. Why does it keep saying that? This should be fine. Show IP route. Oops. Show IP route. Show run include 192.168.12. Yeah, what is it talking about being inconsistent address and mask? What does this even mean? I mean, it should be a valid address. It is a /24. Fair IP route. The network address that we want to reach is 192.168.12.1. That's the mask. And how about we try just interface that's Ethernet 0.1. Right, can we do that? We can't because it's an inconsistent address and mask. What does that even mean? to enter the network ID. That's why my bad. There, that should work, and I don't have to mess with this. So where are we at? To get here, I'm going to use the 192.2.2.2. Can I do this? Oops. Can I ping it yet? No, I can't ping it yet. Why is that the next option? Run, include IP route. I think I need to take some of these things out. All right, so show IP route 192.168.12.1. I don't have that in the table, so I do need to create it. Let's go back here. BGP 101.1. Do we have the same input now? Yeah, we do, except it's inaccessible. Okay, so it looks a bit better. But I'm probably still not going to be able to ping it. Go back to R1, show IP route 3.3.3.3, and it has to go through router 2. Interesting. R1 could ping R3, but can R3 ping R1? It can't. Why is that? Okay. What 3 we have to show IP route. Let's get to 101.101. We're going to send data to 192.168.12.1, which is this interface. And to get here, we have to enter the subnet right here via router 2. I am probably over time with this lesson. I'll probably figure this out for another day, and I'm gonna move on. Thanks for watching.